by the end of this lesson, we will be able to create a system of inequalities that model a real-world problem. Remember, systems have more than one inequality or function involved on the same coordinate plane. So we will be defining variables, setting limits and scales for each variable, and graphing the system to interpret all of the possible solutions. Kyle works part-time for a local contractor, so doing some kind of construction work. He makes $8 an hour with the plumber and $12 an hour when he works with the mason, which usually deals with bricks. $12 an hour with the mason. Okay, but he has some restraints. It says Kyle cannot work more than 10 hours per week. So he cannot work more than 10 hours. So if he cannot work more than 10, he must be working less than or equal to 10 hours per week. And then it says graph the two inequalities that represent how many hours he needs to work at each job to earn at least $100 per week. So now he wants to make more than or equal to $100 per week. Before creating inequalities, we have to set what our variables will be. So let x equal, let's see, what came first? The number of hours with the plumber. So the number of hours working with the plumber. And then we can let y equal the number of hours working with the mason. Number of hours working with the mason. Okay, now we're ready to create our inequalities. It says Kyle can work no more than 10 hours per week. So we said before, that means he must be working less than or equal to 10 hours per week. Well, the sum of the hours at the plumber plus the sum of the hours at the mason must stay under 10 hours per week, or could be equal to. Okay, but there's another constraint. We want him to earn at least $100 per week. So we want him to earn more than or equal to $100. To calculate how much money he's going to earn, we need to say he's going to make $8 multiplied with every hour he works with the plumber and $12 multiplied with every hour he works with the mason. Okay, we want to label each inequality on the grid. So now if I created a system with both of the inequalities that we had mentioned before, we would end up with this picture. So we want to label them. We want to figure out which one's which. So first I'd have to rearrange each equation to see which one is in fact the blue and which one is in red. So let's rewrite x plus y has to be less than or equal to 10. If I subtract x over, I see y is less than or equal to 10 minus x. This is the same as negative x plus 10, which reminds me that the slope should be going down 1 over 1, and it should begin at 0, 10. So at 0, 10, 0 hours with the plumber, working all 10 hours with the mason, I would begin here. It appears that the blue picture will match this inequality. Let's make sure. If I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, it seems to have the correct rise over run, and it's also supposed to be shaded down, which it is shaded downward. So let's label this one x plus y is less than or equal to 10. That means that the other inequality should be represented by this red one. Let's make sure. If I subtract 8x and subtract 8x, I end up with 12y is greater than or equal to 100 minus 8x. We still have to divide every single term by 12, which is going to introduce some fractions. If I reduce my fractions, I could divide both 112 by 4. It goes in 25 times and 3 times, so I end up with 25 over 3 minus, and then 8 and 12 can also be reduced by 4, 2 times and 3 times. So now if I rewrite this, I end up with negative 2 over 3x So my slope is -2 down 2 over 3. And then my y-intercept is a positive 25 over 3, which 25 can go into 24 about 8 times. So it should be a little bit higher than 8. So my b would be at 0, comma 25 over 3, which is approximately a little higher than 8, which is right here. And then does it appear to be going down about 1, 2 over 3? It does. Down 1, 2 over 3, it does. Okay, so now I think it's safe to say we can label this one 8x plus 12y is greater than or equal to 100. Part E asks us to come up with a combination of hours, so x, y, a point, that Kyle can work with the plumber and the number of hours with the mason that would allow him to meet all the constraints. So I chose the point 1, 8, which is right here in the solution set of the overlapping shaded region. If Kyle works 1 hour with the plumber and 8 hours with the mason this week, he will stay under his 10-hour limit for working, and he will make at least $100. I even calculated the sum, and he'll make exactly $104. This is not the only correct answer. You can have any ordered pair that's somewhere in this shaded region of the overlapping section, labeled with S to mark the solution set. Okay, in your packet, please skip problem 2. We're going to come back to that in a little while, but I'd like you to find problem 3. It tells us that Juan is serving on the prom committee and has been put in charge of the snacks. So he wants to buy an assortment of cheeses and crackers. One package of crackers costs $3. But then we're told that the cheese will cost $5 per pound. He has an allotted only $50 total that he can spend on snacks, so he wants to spend less than that amount. Okay, so from talking to his mom, Juan also knows that he will need to buy at least 4 pounds of cheese in order to have enough for his classmates. Mom can estimate the exact amount that he might need to make sure he has enough food for everyone that's coming. So now we want to write a system of inequalities that can be used to represent this situation. To say that I'm going to have a system, I start with this curly bracket, but I don't have my variables labeled. So let's go back to the information in the paragraph. It says one package of crackers costs $3. So I know how much it costs, but I don't know how many we're going to purchase. So we're going to say X equals the number of packages of crackers. And then we're going to say let Y equal the number of pounds of cheese, because we know the cost, but we don't know how many pounds. So now that I have some variables chosen, let's use our constraints. He's only allotted $50. So he could spend less than $50, or he could technically spend equal to, but then later it says he wants to spend less than that. So let's say less than $50 is his goal. So if he wants to spend less than $50, and we're unsure of how many packages of crackers, but we do know it's $3 each, we could say 3 times X. We'll find the cost of the crackers. We have to add on the cost of the cheese, which is 5 times Y. Okay. But his mom gave him another constraint. She said that he needs to buy at least 4 pounds of cheese. At least means greater than or equal to 4. So here, pounds of cheese is going to be reused. Y, the pounds of cheese, must be greater than or equal to 4 to ensure that he has enough for the party. Okay, we're now asked to graph these inequalities on the axes below. So please notice that the first thing I did was label my packages of crackers with the x-axis and the number of pounds of cheese with the y-axis. It's important not to confuse our variables, and we want to make sure we don't forget to label each scale. So before I can decide the scale increments, I need to predict or see what values must be shown. So let's rewrite this first inequality. We want to get it into slope-intercept form. So 3x plus 5y has to be less than 50. If I subtract 3x from both sides, remember we want to isolate the y, we end up with 5y is less than 50 minus 3x. Now I divide every single term on both sides by 5. I now see y is less than 10 minus, and then I keep it in fraction form, 3/5 x. It's okay to keep it in fraction form because it represents my slope, as I notice when I rewrite it. I now see my slope is negative 3 over 5, down 3 over 5, and my y-intercept would be 0, 10. Okay, before I can pick scales, I need to plan ahead. We now know that this line is going to start somewhere at 10 on the y-axis, which I can certainly fit if I count by ones here. This y value, this equation, is a special line. It says y equals a number, so that means it's a horizontal line beginning on the y-axis at 4. And if it begins at 4 and this one's highest value is 10, I know it's its highest value because 10 and then the slope goes downwards, so it's going to be a nice negative slope. I realize that maybe I can spread out these values. Instead of counting by ones, I can count by a half. So this would be 0, and then I would skip a box, this would be 1. Skip a box, 2. Skip a box, 3. The reason for spreading this out is it will make the picture less cluttered. It'll spread out the information so it's easier to read. You could absolutely count by ones, but then it'll be kind of squished down in the bottom of the graph. So 8, 9, it reaches up past the 10 that we need, up to 11. Perfect. So instead of only using about half of the grid, now we're using the full height just about. Okay, predicting values for the x-axis is not as easy. Luckily, we have a horizontal line here, so we know it's just going to go straight across left to right and then have our shading. But for this line, our x-intercept starts at 10, and it's going to start moving downward until I finally hit the x-axis. What's important is anytime a value hits the x-axis, it means that the y, or the height of the point, must have been 0. So if this 5y was 0, if I used 0 pounds of cheese, but no cheese and only crackers, which wouldn't make sense for the party, but just to limit or come up with our constraint, if I bought no cheese, how many pounds of packages of crackers could I get? So that would leave me with all $50 to spend on $3 per package of crackers. So I could buy, let's say, so 8, 3 goes 20, oh, not 8, 6 times to get 18. And then we get 2. So I could buy 16 and 2/3 of a package, but we wouldn't buy 2/3, so I would only end up buying 16. But it means that this line should be hitting the x-axis somewhere between 16 and 17. So I can certainly fit all of the data if I count by ones. So let's do that. Start with 0 and then 1, 2, 3, 4. I like to label every 5, otherwise it gets too crowded. 6, 7, 8, 9. This would be 10. 15, and then it stops right at 20. Now we have a scale or a window that's appropriate for our graph. So let's begin graphing the inequalities to show this system. I would begin at 10, and I have to move down 3 over 5. But it's important that we move down 3 units, not 3 boxes. Each box is only a half. So if I want to go down a full 3 units, I have to go down 2, 4, 6 full boxes. To go down 3 units, 10 drops to 7, and then I count over 1, 2, 3, 4, 5. These are counting by ones. So now I got to drop 1, 2, 3, which is really 6 boxes, and then crawl over 5. So I'm going to drop down 1, 2, 3, so 6 full boxes, and then crawl over 5. Now, before I can connect the points, I realize that this must be a dotted line. Juan said that he wanted to spend less than the $50. He didn't want to spend every single cent that he had. So if I connect this with a straight line tool or a straight edge, I see that it does intersect somewhere between 16 and 17 packages, like we expected. Now we must shade. We want to spend less than this amount. So we're going to shade downward, which is going to be this triangle here. Okay, like we mentioned in class, it's tricky to decide where to label when we haven't seen what the other inequality is going to look like yet. So sometimes I label by the edge or I wait until the end, but then you risk forgetting. So this one I'm going to label down here, 3x plus 5y has to stay under $50. Okay, let's graph the next line. We said it's a horizontal line that begins at y equals 4. This one is a solid line that's going to go straight across. So I'm going to get the line tool. You can grab your straight edge, horizontal line. Now we need to add in the shading. It says anything more than or equal to 4 pounds would be enough. So I have to shade up north or anything greater than this line to show. This would show all the different options for having enough cheese. So now what is important is we find our solution set, which is in this region here. Please mark it with an S. Part E asks us to state a combination of crackers and cheese that will keep him from spending too much and still having enough. I chose 3, 6, which is right here. This ordered pair says he could buy 3 packages of crackers and 6 pounds of cheese and meet all of his requirements. He won't spend more than $50 and he'll also have enough cheese according to his mom's suggestion. At this point in the video, I'd like you to pause the video, try problem 2, so go back to problem 2, try it on your own and then press play to check. Feel free to press play and kind of preview some of the answers if you get stuck. But please make sure that you can create the system of inequalities by identifying 2 variables and then use those inequalities to graph. So pause the video now and give it a try. Okay, hopefully you came up with this system. As you can see, she babysits. Edith babysits for so many hours and she also works at the library, but she wants to stay under this limit of 15 hours per week. So she could work 15 hours or less. She makes $4 an hour babysitting, and then she makes $8 an hour working as a librarian assistant. And we want her to make more than or equal to at least this $80 per week. So this is the system you should have come up with. Now let's look at our graph. If yours does not look like mine, take the time to pause, erase, and modify any mistakes you had. You can see that I rewrote this one in terms of y, and it says that if we start out at 15 hours, if she works all 15 hours babysitting and no hours at the library, we would go down one over one, down one over one to reach 15 hours babysitting. Sorry, no hours babysitting and 15 hours at the library. And it's anything under there, any combination that adds up to be less than or equal to 15 hours. Now the other equation was a little more challenging to isolate the y, but we begin at 10 and we go down 1 over 2, down 1 over 2. It's important that we have number of hours babysitting as our x-axis and number of hours at the library as our y. If yours is reversed, your solution set will have the same answers, but it'll look slightly different on the graph. It'll be kind of like a reflection. So to determine one point that will meet both requirements, I chose the point 5, 1, 2, 3, 4, 5, comma 9, which is about here, lands in that solution set region, saying 5 hours babysitting after school and 9 hours as a library assistant. She'll stay under her limit of 15 hours per week, so she still has time to focus on school and still make at least $80, her goal. She'll end up actually making $96. So this is the end of tonight's video. We're going to save problem 4 for tomorrow's do now. We will be able to create systems that answer real-world problems. It's going to require us to define variables, limits and scales for each, and then we graph the system to interpret and discuss all the possible solutions.